Hey guys, today we're going to talk about the Bohr model a little bit more in depth. So even though the current atomic model is a mixture of Bohr and Rutherford, we'll be using the Bohr model more in depth in class because it's a more simplified version and it's a lot easier to work with, to draw, to visualize. So I totally understand that we've made advances since then, but I do want you to know that we are working with the Bohr model just because it's a little bit more simple. So each atom has three subatomic parts that make the atom up. The first part is a proton, which is a positively charged sphere located in the nucleus with a mass of 1. The second part is a neutron, which is a sphere that has no charge located in the nucleus, which also has a mass of 1. And the last one is an electron, which is a sphere that is negatively charged, located in the electron cloud floating around outside the nucleus. Its mass is so small that we ignore it. It does have a mass, but it's so teeny tiny that it doesn't affect the rest of the atom at all. So we have these three things that we're going to be working with the Bohr model, and we're going to be placing them inside the nucleus or in the electron cloud. We're going to be adjusting them based on ions and isotopes, which we'll get to later. So essentially, you're going to be using these three ideas for the next couple days. If we are analyzing hydrogen, we're given a lot of information from the periodic table. We just need to know how to read it. The first thing that we need to know is the atomic number. The atomic number is up here. It tells us the number of protons and the number of electrons. So for this hydrogen atom, there's 1 proton and there's 1 electron. The mass number, which is right here, it tells us the number of protons and the number of neutrons. So mass is the number of protons plus the number of neutrons. So here, our mass is a total of 1.007. We're going to just round that to 1 because that is so little that it's not going to matter. And I know that I have 1 proton, but I don't know how many neutrons I have. So if I rearrange this equation, subtract 1 from both sides, I actually have 0 neutrons in this example. So the atomic number is the number of protons and electrons. The mass number is the protons plus the neutrons. So with the atomic orbitals, the electrons are the orbits outside the nucleus. These orbits can only have a certain number of electrons in each level, and the periodic table gives us a hint as to how many electrons that can be. So the first orbit can only have so many, the second orbit can only have so many. So as we look across the periodic table, this first row is our first orbit. So the first orbit can have 1, 2 electrons, 2 electrons only. The second row can have 1, 2, 3, 4, 5, 6, 7, 8 electrons. The third row can have 1, 2, 3, 4, 5, 6, 7, 8 electrons. And the fourth row, we introduce this middle section. Now, in college level chemistry, you're going to learn that there are different orbitals and different orbitals fill up at different rates. Technically, this middle section is an extension of the third row. So as we fill this third row, we jump out to the fourth level and fill 2 electrons, then go back into the third level, fill in 10 more, then jump back out to the fourth level again. So this entire section is the third level, this one is the fourth, this one is the fifth, etc., etc. Now, when we fill electronic orbitals, I do expect you to know the order, but when it comes to drawing Bohr models, we are not going to use the center part. So the third row, we can technically have up to 18. The fourth row, we can have up to 18. The fifth row, we add in these ones down here. It gets very confusing after that. So essentially, I'm going to expect you to be able to draw up to calcium in terms of Bohr models, and then the rest of it we'll deal with later in the year. So how to make a Bohr model. First, you place the nucleus in the center. Identify how many protons and neutrons are in that nucleus. Then, identify how many electrons are in the electron cloud. Remember the rules on how many each level can hold, because once the level is full, you have to go up to the next level. So for example, here's nitrogen. We're going to draw the nucleus. And nitrogen, according to our atomic number, has 7 protons. And according to our mass is protons plus neutrons. So 14 equals 7 plus neutrons. There are 7 neutrons also, so neutrons are 7. You have to identify this in your nucleus. Now, I don't mind if it's actually in the center or if you write it out to the side, but you make sure that you have to tell me the protons and the neutrons. According to our atomic number, we also have 7 electrons. So our first row, according to our periodic table, can hold 2 electrons. So I have a rule of how to place your electrons. Always go around the clock in order. 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. So the first row can hold 2 electrons. So 12 o'clock, 3 o'clock. Now that row is full. So what I can do is make a little X to remind myself that I don't place electrons at those 2 locations. Now, since 2 electrons are there, I need to add my second row. That's not really a circle. I already have 2 accounted for, so that means that I have 5 more electrons that I need to place. So start at 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. That's 4 electrons for a total of 6. And I go back to 12 o'clock to place my 7th electron. So notice that they're paired up here. I like placing electrons this way because I can automatically see that this electron is missing a partner, this electron's missing a partner, and this electron's missing a partner. So nitrogen is going to make 3 bonds with another element. So when you get to class tomorrow, what we're actually going to focus on is this idea of building atomic models, building Bohr models, and determining how many protons, neutrons, and electrons are present in that element. So I'll see you tomorrow so we can get to work.